Now, substitution, the other method we've looked at for solving consistent systems, is a little bit cumbersome at times. We want to look at a method called elimination, and we can use this on consistent systems, and you'll see later on inconsistent and dependent systems as well. I want to outline for you the basic method or basic procedure. Our sequence, which will make more sense when you see an example or two, sequence of steps is going to be that we multiply. Now, what does that mean? Make it worse, I'm going to say multiply with strategy. We're going to multiply one of our equations, or perhaps both, by a constant, with a view to getting rid of a variable, hence the name elimination. We're going to add. We're going to solve whatever we're left with, and it's usually pretty straightforward. Then we're going to substitute back in our number into another equation, and of course we're going to check. Let's see what those very simple looking words actually mean. Let's begin with an example that does not require any multiplication in the first step. We'll take the system 3x plus 2y equals 1, and 5x minus 2y equals 23. Now, the first step in our process was to multiply with strategy. But our strategy is that we're multiplying so that we can make one of the variables disappear. If I look at these with a view toward my second step, when I add these equations up, I have a 2y and a minus 2y. If I just added them right now, the y's would go away, and I'd be down to one equation and one variable. So I don't have to do anything with multiplication. The strategy's already taken care of. So we'll move right on to the second step, which is add. And I'll just draw a line and go right away. 1 plus 23 leaves us with a 24. 2y minus 2y leaves us with nothing. And here we have an 8x. So now we have a much simpler equation, 8x equals 24. And this is quite straightforward to solve, which is, of course, our third step. We'll divide each side by 8, and we'll have x equal to 3. We have one of our variables solved for. We need to go back, substitute back, and solve for the other variable. In this case, that'll be y. So we'll just pick one of the equations. Let's take, for instance, 3x plus 2y equals 1. And everywhere I have an x, I'll go ahead and substitute in a 3. So we'll have 3 times 3 plus 2y equals 1. Well, then 9 plus 2y equals 1, and this is a familiar friend to you. We're going to subtract 9 from both sides, and we'll end up with 2y equals a negative 8, and then we'll divide by 2, and we find that y is equal to negative 4. Again, we're working with a system of two equations, so our solution is an ordered pair. In this case, the ordered pair 3, negative 4, again, often presented in the answer keys with the set notation. That's the end of this example.